Hello, guys. Mr. Collins here. I want to take a few moments to talk with you about how to determine what to graph on each axis of a graph. To make it linear is typically why we do this. The other reason might be, hey, what we want the meaning of the slope to have a particular meaning. And so what do you graph on each axis to get a linear graph with a particular meaning for a slope? This will come up in almost every lab in AP, and it could come up in some of your practice questions as well. There are 3 steps we will follow in doing this. Step number 1, look at your formula sheet and find the formula that relates your different variables. Step 2, you want to rearrange that equation, and sometimes you don't need to. Sometimes you can skip step 2 if it's already in the right order. But you will often need to rearrange the equation so your independent and dependent variables, those are 2 variables you're relating, are on opposite sides of the equal sign. Then we're going to compare it to y equals mx plus b. And the way we will do that is to put into that little chart I made at the bottom of the screen where the y-axis information is on the left. So on the left here, you have y-axis information, which is equal to the slope, your x-axis, and the y-intercept. Now, it's typically your dependent variable. That's the thing that you're recording what happened to it. And the independent variable is here the thing that you're changing. And so the independent variable is typically x-axis, dependent is y-axis as tradition, but it doesn't have to be that way. And here's a nice little thing. The College Board AP Physics isn't grading that. They don't care. Just as long as you have one or the other. So you can get those reversed, it will still be okay. All right. So let's go ahead and look at an example. A student collects data on the velocity of a golf ball after falling different distances. So what are our variables? We have a velocity and we have a distance that it fell, which I'm going to write as a displacement. You could call it the position it was at. And if it falls, or the velocity after it falls, it's probably going to be a final velocity because it's going to get faster and faster as it falls. So we need to find a formula. This is step 1. Find a formula on your formula sheet that relates your final velocity to your distance. If you want to pause it now and do that on your own, great. If not, I'm going to go ahead and find it here. And we're going to have VF squared equals VI squared plus 2A delta X. Okay, that's our equation. There's a little bit of rearranging I'm going to do. I'm just going to move this VI squared over to the end of it so it fits more with y equals mx plus b because the variables I'm comparing are going to be at either side of the equals, and this thing that's added needs to go at the end to be in the proper form. So all I'm going to do is do VF squared equals, I'm jumping now to the 2A delta X. 2A delta X, and the very last thing will be plus VI squared. We can put that in our chart at the bottom, just as it is. VF squared would be there. And now we have some options here. What do I want to put on the x-axis? Well, that would be the delta x. What do I want to put in the y-axis? 2a. And that leaves my y-intercept as the initial velocity squared. There we go. Okay, the initial velocity squared. I will say there's some options. If I prefer to move that 2 over, and I could graph the 2 on the x-axis, and that would leave my slope as a. But this tells me what goes in each place. Now I'm just writing down the formula across this thing. So if I graph on my y-axis the final velocity squared, and on my x-axis the displacement, that leaves my slope as twice the acceleration, and my y-intercept is the initial velocity squared. I could, if I prefer to change things, I'll bring up a toolbar so I can move this. We'll erase. Takes me a minute to switch. I'll get rid of that too. Okay. Now I have an option to move the 2, and I could put it over here. What if I group the 2 with the delta x? Well, that's fine too. If I graph on my x-axis 2 delta x, now my slope is the acceleration. Either way, it's okay. They're both valid ways to graph it, It just changes the meaning of your slope. If I'm graphing 2 delta x on my x-axis and vf squared on my y, then my slope meaning is the acceleration. And so and both of those are going to be a linear graph, by the way. Following this method always produces a linear graph. So here's my graph. If on my y-axis I graph vf squared, and on my x-axis I do 2 delta x, I expect my slope of this line to be equal to a. So you're going to measure the rise over the run. That's your slope. And so I'm going to grab my toolbar and change colors real briefly. Okay. So the rise, how far the graph goes up, divided by the run, how far it goes over, is your slope. That's your run. This is your rise. And the slope equals the rise over the run. Okay. And I got a little sloppy there, but that's the idea of it. The rise over the run gives you your slope, and that would equal the acceleration here. This example. You will need to probably do a calculated column of the 2a delta x or the vf squared. If you took data on final velocity, so you have your data table with vf and delta x, and of course you got your numbers down here below it, numbers down there below it. You don't necessarily have vf squared, so you're going to want to make a new column of vf squared. And all you're going to do is take the numbers in the column for final velocity and square each one of them. That's your vf squared. Just like you'd make a calculated column for 2 delta x. It's easy enough to do. You take your data under delta x, multiply it by 2. So whatever data point is here, it's 2 times that data point. Okay, so that data point is 5. You would have 2 times 5 or 10. I wrote almost like 20 there. Let's make that 10. So if your first data point is 10, then 2 delta x will be 20. And if your first velocity, well, you get the idea. I'm going to go through all of it, but you have to make a calculated column for those. All right. So in the next example, a student collects data on the force of gravity between two masses at different locations. How could they graph this data so they end up with a linear slope? So we're comparing the force of gravity between masses at two different locations. So the distance between those is typically given as r, or the distance between center masses is given the symbol r. And the force of gravity is F sub g. If you haven't had it yet, you'll learn soon. The force of gravity equation is big G m1 m2 over r squared. That is the equation we're going to use. Okay. Now I want to write this where I compare FG and R. So I'm just going to rewrite that equation where I specify what's going on with FG equals, I'm going to write the G m1 m2, and then I'm going to space out just a little bit 1 over r squared, because that's what I'm comparing here to there. And that would go on the y-axis, force of gravity. On the x-axis, 1 over r squared. It thinks I'm, oh boy, that's 1 over r squared, and it's speedword on me. I lost my pen. All right, let's. One over r squared. So that's r squared. That would leave my slope as this, G m1 m2, and my y-intercept, well, there wouldn't be one. It should be 0. Okay, so this is one way to graph this linearly. If you were to graph on your y-axis the force of gravity, and on your x-axis 1 over r squared, you get a linear graph whose slope is G m1 m2. But what if you wanted your slope to be G? Well, that can be done as well. You just take m1 m2 and graph it with your axis over here. So if I graph force of gravity versus m1 times m2 over r squared, then my slope is G. So I can sort of modify or move things around depending on what I want. And yes, you do have to make a calculated column of m1, m2 over r squared. Okay, so you're going to have to calculate that to get those data points to graph it linearly. One last example. A student watches and records should be and records the velocity of a coffee mug going around the circle in a microwave. The student repeats this experiment with a mug at several different radius. How can you graph the data so that the slope is linear? What will be the meaning of the slope? So again, our first step is just find an equation that relates our variables. So we have a velocity v and going around circle in a microwave at different radiuses. So we have to compare velocity to radius for an object going in a circle. And our formula for that, and you may not have had this yet, but if you haven't, it's okay. I'll tell you the formula is A equals v squared over r, the circular motion formula. And if you wanted to find that, I apologize. You could have gotten it on your own, I'm sure, by looking at the formula sheet. Now, if I'm comparing this v to r, are they on the same side of the equation? No. I need to somehow rearrange them so they are. So I'm going to multiply both sides by r. I'll get AR equals v squared. Okay. And I want to switch sides, so I'll just write this as v squared equals AR. And I can use that, and I can put v squared here, A and R there, and that will work to give me a linear slope where on the y-axis I graph v squared, my x-axis I graph the radius, and my slope would equal the acceleration. There is another option. What if I took this formula and I square root of both sides? Well, I get v, because the square root of v squared is v, equals the square root of AR. Well, I can graph that as well. If on my y-axis I just graph v, then on my x-axis I graph the, I'm too close to the toolbar writing down here, and it just wants to mess me up. All right, so let's put this somewhere else. If on my y-axis, I'll do that. I'll switch colors. All right. So if on my y-axis I graph, v, and on my x-axis I graph the square root of r, it leaves my slope as the square root of a. Okay. And so you're probably wondering, well, how do you know which one to do? Which one is right? They're both right. It just depends on what you want. Do you want your slope to be acceleration or the square root of acceleration? Okay. And both graphs will be linear. You could graph v squared versus r. So in blue, you're graphing velocity versus the square root of r. And if you did the green on the bottom, you're graphing velocity squared versus just r. And so either way, you get a linear graph, but the meaning of the slope will change. There in green, my slope is acceleration, where in blue, the slope is the square root of the acceleration. Okay? In either way, you can calculate the acceleration from the slope. But that's how you pick the what to graph on each axis based off of your scenario. Hopefully that was helpful to you.